Okay, welcome back. This is the second part of the first lecture. It looks like I went a little over 15 minutes and everything was fine, so I'll probably be a little bolder next time. I just don't want to re-record this one more time yet. So anyway, here's another list of other worthwhile resources. I'm not going to spend much time on this. I think you guys recognize the stuff is out there. Lots of good content out there. Again, it takes a lot to put it together and put it to use. We're going to try to focus on stuff and putting it to use. The other thing I mentioned before is the ethic we want to use. If we do develop anything worthwhile in this course, we want to use this creative content approach with it. This is something that's an alternative to copyrights. This basically says that you're putting this out there for the good of the community, and this is basically the mode I hope we go to. This is creative content. It's called attribution. Means that it should be if somebody uses your content, they should give you credit in that. Say you want it's by, tell who the author was, it's by somebody. And then this is a share alike recycle symbol, meaning others can take your stuff, build on it, and you encourage that. And we want to take that, and then if you might take it back and say, this is I made the original, it was built on by John Smith, etc. I took it back and did it again, and that little recycle mark means that hopefully things get better, and better. And that's the way we like to do things. And I think that's really a good ethic. When you do, anybody that writes a textbook, whenever I look at textbooks, I can recognize where all this content came from. The person whose name is on the front of the textbook, all they did was compile this great stuff that was made by other people. And we're just going to acknowledge that, and we're not trying for commercial reason. Nobody involved with this process is making money off of it. Okay, the last part of this is probably the most important part, and I do want feedback and comments on this, is I'm hoping we can accomplish a few things. And these are goals that I say are beyond the standards. And here's what I'm hoping we can do is get some core messages into students. First of all, science and technology is a primary engine of human advancement. This isn't quite the language I would use with ninth graders, but I think you know what I'm saying. Our lives are better, we better traveled, better informed, longer lived, all this because of technology. And I'm a big geek on technology. I'm really a believer in this. I think it really has made the human race really improved our lot. It's not all unicorns and rainbows, but on the whole, it's pretty good. Second big point is science and technology communicate in the language of mathematics. And that math goes beyond simple numbers, and they represent dimensional quantities we can understand. And dimensions is something I'm going to try to make a big deal out of. Dimensions we use all the time: yards per carry, miles per gallon, and sometimes you get used to miles per gallon. It's kind of it's a very subtle but important thing. Over in Europe they talk about how many liters of petrol it takes to get you 100 kilometers. So it's basically inverse units. Not a real easy comparison back to miles per gallon, but it's the same basic thing. And you want a small number of liters of petrol, obviously, to take you 100 kilometers, whereas we want high miles per gallon. We're going to talk about these units a fair bit in this class, and that's going to be, I think, something we're going to hammer in this thing. Thirdly, there are useful and great jobs in science, engineering, and technology. Just use myself as an example. I love what I do. I'm privileged to do what I do. It's all based on the fact that I've kept going and been stayed at school as long as I can, including now. But I get to travel right now as I do this lecture. I'm in the Bahamas, and I can actually see the Caribbean from where I'm sitting right now. So it's got its perks, but there's a lot of work. I'm doing this lecture kind of late at night. I've done it once before. And then lastly, there's some great rewarding jobs, and these students can have them, and we want to get that across. I think that's a really important point. That's not in the standards, but the standards are what we work with. I think you're all familiar with this. It's simple at one level, at mind-numbing if you really dig into it. We're going to look at high school physical science. That's what the state says. The state doesn't mandate it has to be in any order. Columbus City Schools, there's this pacing guide that is used more or less, I understand. And we're going to try to fit things in largely to this pacing guide And the way material science is going to fit in is we're going to fit it into nature of science, fit it into motion and force. And again, what I'm going to try to do is blow this up a little bit. I'm not making people seasick, but at least you might be able to read it now. Motion, force, energy transformations, there's a lot we can do. One of the things that both these hit is the idea of a spring. Springs store potential energy. You're also stretching atomic bonds. Elastic properties are basic materials properties. Gets into energy and motion, forms of energy. We can do things with freezing and melting. Latent heat goes in and out. Earth and motion, we're not going to do much with. Classification of matter, going to do a lot with. I think we can do a lot to augment atoms in the periodic table. And chemical bonding, we're going to do a lot with this. Polymers, metals, ceramics, all this stuff. There's a huge amount of chemistry we can do with this. Interactions of matter, huge amount we can do with this. Observation of the universe, we're not going to hit, but there's lots of ways, material science, we can develop some themes, run them right through the 9th grade, and I really think give your students some things that they can feel comfortable with and latch on to, let's hope. So here are the themes. Here's the existing themes that are in there. Energy is a big one. Conservation, forms, potential, waste heat. Atoms and applied chemistry. Classifications of matter, we can nail that. Reactions we can do a lot with. Properties we can nail. Extrinsic and extrinsic. Structure of matter, we can nail this with great examples. We'll work into that. New themes I think we can bring in that aren't really in the standards, and maybe they fit somewhere else. I'd welcome discussion of this. Really interconnections between science, technology, engineering, mathematics, we can hit that. How that fits in society, how we modify material properties is really important and simple things. I think you can really give your students a sense that they can do some cool things just with some simple demos. Using science to make stuff, we're going to make some little cast, very cool cast objects. I'll show you how that's going to be done later on. It fits together with loads of other stuff. Units and calculations, again, this is something we're going to hit hard. I think we can have students invent their own measures as we go. Logarithmic scales we'll use to compare wildly different measures. This is a problem that I run across all the time. It's a different way of thinking quantitatively. It's an important one. Lab techniques, methods of measuring, and some things that we'll use as connectors between these things, mechanical behavior and springs and elastic properties, structure and properties of materials, and reactions and processing to do useful things. Those are going to be things that we're going to hit. The way we're going to do that, here's a curriculum again, and just showing this is, I think, some of the topics that we will hit. Study of matter, and usually forces in motion go before study of matter. But the things in red are the things we can do a great job of. Electricity, thermal energy, we can do a great job of. You'll see in a little bit. Transformation of energy, conservation of energy, we can do a great job on. These are topics that we are going to develop from the ground up, very simply, hopefully, in a way that your students can get. And I want you guys to reality check me to figure out if this is something that the students will or won't get, because I literally look at this stuff in some form or another every day. So I'm awfully close to it. I can't see the forest from the trees, but I think I can, from this vantage, show where this is nicely. So what we're going to do is I've got some students at OSU who are really game to help, and we're going to make some kits that will be available to you all. We're going to make some standard materials reference kits, give you some plates of aluminum, steel, copper, glass, all of the same size, so you can really try to understand the properties of these. We'll do some things with some standard wires. We'll develop some kits so we can do standard tension testing for strength and stiffness. We can do some electrical measurements with simple things like a battery, an ammeter, and a voltmeter. And we can develop some kits for doing materials processing, for processing polymers, ceramics, glass, metals, making metals from a rock, making composites. And these kits will be used for these activities. So we can look at the properties of materials, again, look at these dimensions that they work, do this in thermal, electrical, mechanical, look at storage and energy transformation. And one of the things this is really gets close to manufacturing. Manufacturing, we want to make good materials. We also want to make useful, high efficiency shapes out of this. And so that's a way we can do some things that really connect science to real stuff. And again, materials and manufacturing. Again, emphasize these are ideas. Let's see how these unfold. Bear with me a little bit, but please comment. And the whole goal here is to do things that are useful for your students. And I think you all as instructors have to be beyond where the students are at, but I don't want to go too deep into the weeds. Okay, here's a possible lab that I call Fun with Wire. We can do a lot with wire. This is McMaster car. Go to McMaster.com, put in aluminum wire. This is what comes up. You can put in aluminum wire, iron wire, copper wire, nylon with various gauges, glass. We can get glass fiber. And so these are nice, very simple, slender shapes that we can get. And just again to zoom in on this thing a little bit, I can get aluminum wire, all these different diameters. I can buy for $150, 37,000 feet, like 7 miles of aluminum wire if you want it. So again, you can do a lot of labs with 7 miles of wire. So what kind of labs could we do with wire? Well, for example, what we can do is take this piece of wire, put a force on the end of it. Forces are something that we care a lot about. Pretend that says F. And figure out how strong it is. Well, what are the units of strength? Their force per area. We call that stress. We can work through that. And I think we can have students discover how much force does it take to break 1 wire, 2 wires, 3 wires. Well, that should be 3 times the strength. And then you can play with different gauges. You can test a small one. Can you predict what a bigger one would be? Maybe 1 or 2 students would be able to predict that properly. By the time you go up bigger wires, you should be able to predict, maybe little contests as to what the strength of the wire should be. Strength shouldn't depend much on length. You can also do similar things with measuring wire resistance. And resistance will vary linearly with length and vary with cross-section. And if this isn't too advanced, we can teach students basically with this concept to know if you get this down, you're halfway to becoming an engineer, no kidding. This is, if you can work well with dimensions, you can solve most problems on engineering exams. This is really core. I think this is a really thing we'd like to hit. I would on that. So here's my lecture plan. Here are the 10 lectures I'd like to give, 1 a week. So what we've done today is course goals and methods. Next lecture we'll talk about sort of some materials, time, and history. Get into some units there. Then we'll get into force in the spring. Energy transformations, use a spring to design a catapult, building on what's here. Energy temperature phases in the phase diagram, melting and solidification and melting and energy going in and out. We'll see how we do with that, but then we can also use that to make low melting alloys, which are fun. And we can do some cool castings, make some things you'd never think you'd be able to make. And classifications of matter, first part, general properties. We'll talk about mechanical and possibly electrical properties. We'll talk a fair bit about structure of metal, materials. We'll talk a fair bit about how we can control reactions and actually make things, talk about some demos you can use in your classroom. And then the last one, we'll talk about the example of sustainability in the automobile. And I've got pretty clear ideas what can be done with all of this. Again, this is all tentative. If this is stuff that's way beyond what your students can do, let me know. We won't do that. We'll do something else. I really, really, really want this to be a conversation. So in that vein, here are the assignments. Every week we have some assignments. Usually it's a quiz, but this time it's an assignment. 2 things. First, introduce yourself. I want everybody to make a PowerPoint. If you don't have PowerPoint, let me know, but I'd like to just have a few words of your backgrounds, your picture, where you teach, what you teach, maybe how long you've been doing it, what you're passionate about, what you might want to get out of this. Inside OSU, so we can line people up with research projects. Primarily, this is a slide about me. This is about what it should look like. It's a picture. You can draw horns on pictures, whatever. But a little about where you came from, what you do, maybe a picture of what goes on in your classroom if you've got something handy. Don't spend more than about 20 minutes on this. If you spend more than 20 minutes, you're doing too much, but please try to pull something together. This could be very useful when we're trying to promote this program to others to show who's involved. And also, I'm going to put these up so you all can learn a little bit more about each other. Assignment 2. This is a free-form feedback on what we're doing so far. Anything. Doesn't need to be long, doesn't need to be fancy, but comments on where you've been, what you like, what you don't like. You know that you've had Andy to your high school for visits classroom. Comments on that. Comments on what we do at COSI. Comments on the curriculum development you've been doing with Terry and Howard. Any of that. And if things are sensitive or you're not comfortable with it, it can be anonymous. It won't go any further than me. We just want to use this to make the program better. Okay, and both of these things. So with the introduction of yourself, there's a template that's in the content section that has that little one with my picture in it, and then with this one, it can be any form you like, Microsoft Word. I'd prefer not an email. Both of these things should go into the Dropbox on Carmen, and I'd like to have it in a week by January 14th. And that's basically it. So please put it in the Carmen Dropbox. If you send these to me by email, I'm too disorganized, basically. Please put them in the Dropbox, and we'll compile that. You'll get your points, and you're on your road. No quizzes or anything else. Again, I want to be actively engaged in this. My phone number, email is there. Write me, call me. Give me feedback on what you think may or may not work. Make suggestions. We want to come up with a few things that lots of people hopefully can use, and we'll show it works hopefully in a couple classrooms here possibly, maybe not this year, maybe next, and then if it works we'll go elsewhere with it. That's it. I just want to end by just saying how excited I am about this whole program. We've got a great group of people doing the MSP thing. Very happy with what I see from the energy and enthusiasm I see from you guys at the COSI events and all. And I think we have an opportunity to do something really good for the next generation of students. That's it. I will make another lecture soon, and again, it's a privilege to work with you all. Take care. Bye.